Hello everyone, I'm Regine Lamosteo. I will discuss the introduction number system conversion. So, what is number system conversion? The number system or a numeral system is a system of naming or representing number. We know that number is a mathematical value that helps to count and measure object, and it helps in forming various mathematical calculation. In other words, number system conversion deals with the operation to change the base of a number. There are a variety of number systems such as binary numbers, decimal numbers, hexadecimal numbers, and octal numbers. So, in algebra, a decimal number can be defined as a number whose whole number part of the fractional part is separated by a decimal point. What it is for? We use decimal every day while dealing with money, weight, length, and etc. Decimal numbers are used in situation where more precision is required than the whole number can provide. For example, when we calculate our weight in the weighting machine, we do not always find the weight equal to a whole number on the scale. Second is, what is a binary numbers? A binary numbers is a number expressed in the base 2 numeral system or binary numeral system, a method of mathematical expression which uses only two symbols, typically 0 and 1. What it is for? Computers use the binary number system to manipulate and store all of their data, including numbers, words, videos, graphics, and music.
Hi guys, my name is Cheryl May Emily Hoare, and today we will be discussing both the octal and the hexadecimal number system. So let's start with the octal number system. The octal number system has a base of 8 and uses the numbers from 0 to 7. The octal numbers in the number system are usually represented by binary numbers when they are grouped in pairs of 3. What it is for? The octal numbers have many applications and importance, such as it is used in computers and digital number system. What is hexadecimal number system? You might be wondering. Hexadecimal describes a base 16 number system. That is, it describes a numbering system containing 16 sequential numbers as base units, including 0, before adding a new position for the next number. Note that we are using 16 here as a decimal number to explain a number that would be 10. The hexadecimal numbers are 0 to 9 and then uses the letters A to F. We show the equivalence of binary, decimal, and hexadecimal numbers. What it is for? Hexadecimal is a convenient way to express binary numbers in modern computers, in which a byte is almost always defined as containing 8 binary digits when showing the contents of computer storage. For example, when getting a core dump of storage in order to debug a new computer program, or when expressing a string of text characters or string of binary values encoding a program or HTML page. One hexadecimal digit to represent the arrangement of 4 binary digits. 2 hexadecimal digits can represent 8 binary digits or a byte. Why do we need to do conversions? When we type some letters or words, the computer translates them in numbers, as computers can only understand numbers. A computer can understand the positional number system where there are only a few symbols called digits, and these symbols represent different values depending on the position they occupy in the number. Thank you.
Good morning, everyone. I am Maria Eunice Anderong, and today I'll be discussing to you on how to convert decimal number in binary, octal, and hexadecimal. Converting decimal number into binary need this easy step. First, divide the decimal number by 2 because binary is a 2 base digits, right? And second, get the integer quotient for the next iteration. Third, get the remainder for the binary digit. And lastly, repeat the step until the quotient is equal to 0. Example. So as you can see on the slide, we have the decimal number of 13 in 10 base number. We need to convert that into binary 2 base digits number. So on doing that, we need to follow the step. 13 divide 2. So we can get the quotient 6. And we have the remainder 1. Kung atong i-divide ang 13 divide 2, makakuha ta og 6. and dividing it na tayo nabilin na 1. So, consider na remainder na to. Since na sa ikaduhang step, kailangan na to ang iteration or quotient na 6 because i-divide na to siya outro sa 2. So, we can get the 3 quotient again, and there is no a remainder, so we should put there 0. And on the third, we need to get again the 3 for the next iteration to divide it in 2. So 3 divided 2 is 1. So we have the remainder again 1. And then since 1 be divided in 2, we have the 0 quotient there. So the 1 left on the quotient will be the remainder. So these are the remainder we have on binary base. We have to follow the MSB or the most significant bit. So from the bit up to 0 bit, that's the bit that we must follow. So 1, 1, 0, 1 to the second base number. That's the easy way on converting decimal number to binary. On how to convert decimal number to octal. As you can see on the step, they are almost the same. Nagkalahi lang sila on the first. Right? On binary, we divide the decimal number to 2, but in this case, sa octal, we should divide the decimal number to 8. Why? Because 8 is the base number of octal. The same with the following hexadecimal number. We should divide it sa ilang mga base. So, we have the decimal number 7562 divide 8. So, we have the quotient 945. Natay mabiling nga remainder nga 2. So, 945 quotient integers, divide na po nato to sa 8. Base niya, makakuha ta og 118. We have the remainder 1. And then 118, divide na po nato sa 8. Makakuha ta og 14 quotient. And we have the remainder 6. 14 divide 8 is 1. And we have the remainder 6. Kasi di man nato ma-divide ang 6 sa 8. So, considered na remainder na siya. So, 1 divide 8, of course, 0. And the 1 na nabilin is considered as remainder. The conversion gikan sa decimal, we need to follow the MSB, the most significant bit. Gikan sa 4 bit hangtod sa 0, so 7562 decimal number in 10 base is equal or converted to 166128 base. So let's move on converting decimal number to hexadecimal. Again, on converting decimal number, we need to divide the number on the base. So we have 16 base. Atong example dire, ang atong gigamit na decimal number is the same sa octal, 7562. Divide na to siya sa 16. Makakuha ta og 472. And natay remainder na 10 kung sa decimal. Again, and then, ito na punta sa quotient integers na 472. Divide na po nato siya sa 16, makakuha tag 29. We have the remainder 8 and 29 quotient divide to 16. Again, we have the quotient 1 and remainder 13. And 1 divide 16 is 0, so ang 1 na nabilin is considered as a remainder sa decimal number. Now, as you can see there on remainder hexadecimal, why is that A ang gibutang? And sa and sa decimal na remainder is 10. Ang remainder na 10 sa number 10 sa decimal, it is A. A na siya sa hexadecimal. And ang 8 is 8 gihapon sa hexadecimal. Ang 13 na remainder is D sa hexadecimal. And 1 is 1. So, walahi ang decimal numbers sa hexadecimal numbers. If you have the table, makita po ninyo dito. So again, on writing it, we should follow the MSB, most significant bit, hantod sa least significant. On the following conversion, let me pass the turn to the others.
I am Hannah Kafia Mailan, and I will explain the binary conversions. Binary to decimal conversions. Bits in binary numbers represent one of two values, 0 or 1, and are combined to form binary numbers, because each column of binary numbers is twice as heavy as the previous column. Binary numbers are base 2. Column weights in binary are 1, 2, 4, 8, 16, 32, 64, and so on. Again, from right to left. If you work with binary numbers frequently, remembering these powers of 2 up to 216 will save you time. Binary to decimal conversion explanation. So first, you need to think of binary numbers. Example is 1, 1, 1, 0, 0, 1, 0. And next, kailangan nimo butngan og appropriate value, which is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 2 to the power of 5, and 2 to the power of 6. Mangutan na ka, ano siya, 2. Because, mo na siya ang base, ang binary na ay base 2. So, pag na, always ignore the 0. Just focus sa 1. Okay, mo na ang 1 sa pag-solve. So, 1 times 2 to the power of 6 is 2 to the power of 6. Imo na siyang isulat. Kaya nga naman dyan na siya. And then, so, 2 to the power of 6 is equivalent to 64. Plus, 2 to the power of 5 is equivalent of 32. Plus 2 to the power of 4 is equivalent to 16. Plus 2 to the power of 1 is equivalent to 1. And then, imo na siyang i-plus tanan. 64 plus 62 is 96. 16 plus 1 is 17. I-plus naman siya. 96 plus 17 is equal to 114. So, 114 is the equivalent of 1110010.
Binary to octal conversions. In binary to octal conversions, we learn how to convert a base 2 number system to a base 8 number system in binary to octal conversion. Because we cannot convert binary to octal directly, we must first convert binary to decimal, and then the decimal number to the equivalent octal number system.
Next is binary to octal conversion. So first, in binary to octal conversion, you need to think a binary number. 1, 1, 0, 1, 0, 1. And second, separate binary numbers into group of 3. Separate. Rewrite it. Then, you put nga siya og appropriate value. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Same lang Japon sa pikas. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. And as always, ignore the 0. Focus on 1. So, rewrite. Then, 2 to the power of 2 is equivalent of 4. 2 to the power of 1 is equivalent of 2. 2 to the power of 2 is equivalent to 4. And 2 to the power of 0 is equivalent to 1. And then next is just add the numbers. 2 plus 4 equals to 6. So 4 add to 2 is 6. 4 add to 1 is 5. The answer is 65. Para dili mo maglibog kung asa nakabikuha ang 65. And 5, dili na siya i-add because gi-separate na nato ni siya. So all we need to do is combine the number. So makuha na siya na 65. And then you're wondering asa hindi ka ng 8 because 8 ang octal have base 8. So 65 to the base of 8.
Binary to hexadecimal conversions.
The hexadecimal number system makes it easy to convert large binary number into a compact and smaller groups. There are several methods for converting a binary number to hexadecimal number. You can convert using either direct or indirect methods. To begin, you must convert binary numbers into another base system. Example, into decimal or into octal. Then, you must convert it to the hexadecimal number. Binary to hexadecimal conversion. So first, mag-isip na po binary numbers like 1, 0, 1, 1, 0, 1, 1, 1. And then, in binary to hexadecimal conversion, separate binary numbers into group of 4. So separate. Rewrite 1, 0, 1, 1, and 0, 1, 1, 1. And then, ibutang na po nimo ang appropriate value of each number. So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Same lang dyan sa pikas. And then, ibutang na po sa 1. Again, always ignore the 0. So 2 to the power of 3, 2 to the power of 1, 2 to the power of 0, then 2 to the power of 2, 2 to the power of 1, 2 to the power of 0. 2 to the power of 3 is equivalent to 8, plus 2 to the power of 1 is equivalent to 2, plus 2 to the power of 0 is equivalent to 1, and 2 to the power of 2 is equivalent to 4, plus 2 to the power of 1 is equivalent to 2, plus 2 to the power of 0 is equivalent to 1. 8 plus 2 plus 1 is equal to 11, and then 4 plus 2 equals to 6 plus 1, 7. So 11 corresponds to B. Why? Because in hexadecimal, 10 is equivalent to A, 11 is equivalent to B, 12 is equivalent to C, and 13 is equivalent to D. So the answer for this conversion is B, 7, base 16. So you're wondering why 16? Because hexadecimal is a base of 16. So the equivalent of what? 1011, 0111 is B7 to the base of 16. That's all.
Hello, my name is Parisaki Kapsati. So today, I am going to discuss about octal conversion. Octal decimal. The octal numeral system, or oct for short, is a base 8 number system and uses the digits 0 to 7. That is to say, 10 represents 8 in decimal and 100 represents 64 in decimal. How to convert from octal to decimal? A regular decimal number is the sum of the digits multiplied by 10. Example number 1. 100 37 in base 10 is equal to each digit multiplied with its corresponding ten. 137 in base 10 is equal to 1 times 10 raised to the power of 2 plus 3 times 10 raised to the power of 1 plus 7 times 10 raised to the power of 0 is equal to 100 plus 30 plus 7. Octal numbers are read the same way, but each digit counts 8n instead of 10n. Octal to binary. Converting from octal to binary has a very straightforward method because of octal numbers are a shortened version of binary string. Remember that each octal digit represents 3 binary digits. Therefore, one octal digit should give 3 binary digits, while octal can be converted to binary indirectly. First, to the decimal, then to binary. A direct method to convert octal to binary with steps as follows. So these are the steps on how to convert octal to binary. Step 1. Write down the octal number separating the digits. Each octal digit represents the 3 binary digits and therefore is equal to a power of 2. The rightmost digit equals to 2 raised to the power of 0 times 1. The next one equals 2 raised to the power of 1 times 2. And the leftmost one equals to 2 raised to the power of 2 times 4. Write these numbers 4, 2, and 1 below the octal digit. Step 2. Determine which power of 2, 4, 2, or 1 sum up to your octal digits. For example, if one of your octal numbers is 6, this means 4 and 2 sum up to 6, and 1 is not used. If your octal number is 2, only 2 is used and 4 and 1 are not. Step 3. Write down 1 below those 4, 2, and 1s that are used. Write down 0 below those are not used. Step 4. Read first and zeros you just wrote from your left and right. You will get your binary number. So 456 raised to the power of 8 is equal to 10100111100 raised to the power of 2. Octal hexadecimal. Hexadecimal number system provides convenient way of converting large binary numbers into more compact and smaller groups. There are various ways to convert a binary number into a hexadecimal number. You can convert using direct methods or indirect method. First, you need to convert a binary into the base system, example given, into decimal or into octal. Then you need to convert it hexadecimal number. Steps in converting octal binary hexadecimal. Step 1. Convert 56 raised to the power of 8 into binary in order to convert the octal number into binary. We need to express every octal value using 3 binary bits. Binary equivalent of 5 is 101 raised to the power of 2. Binary equivalent of 6 is 110 raised to the power of 2. 56 raised to the power of 8 is equal to 101 times 110. So 110 raised to the power of 2. Step 2. Converting octal decimal hexadecimal. 46 raised to the power of 10 into hexadecimal. So 1612 minus 4 is equal to 2e raised to the power of 16. So the answer is 2e raised to the power of 16. So that's the hexadecimal.
Hi everyone, my name is Marvin and Cornelio. I will discuss my topic, which is hexadecimal conversion. Hexadecimal to binary. Converting from hex to binary is straightforward since hexadecimal numbers are simplified version of binary strings. You just need to remember that each hex value will produce 4 binary digits. In converting hexadecimal to binary, first step, write down the hex number. If there are any, change the hex values represented by letters to their decimal equivalent. Second step, each hex digit represents 4 binary digit and therefore is equal to a power of 2. The rightmost digit equal to 20 simplified by 1. The next one is equal to 21 simplified by 2. The next one is equal to 22 simplified by 4. And the leftmost one equals to 23 simplified by 8. Write this number 8, 4, 2, and 1 below the next value. Step 3. Determine which powers of 2, 8, 4, 2, or 1 sum up to your hex digit. For example, if one of your hex values is 10, this means 8 and 2 sum up to you 10 simplified by 4 and 1 are not used. If your hex number is 2 only, 2 is used, 2, 4 and 1 are not. Step 4. Write down 1 below those 8, 4, 2, and 1 that are used. Write down 0 below those that are not used. Step 5. Read the first and zeros from left to right to get the binary equivalent of the given hex number. Hexadecimal to octal conversion. Hexadecimal numbers are numbers which each have base 16. So, it is used 16 different digits to represent the numbers. It is denoted as H16, where H is hexadecimal number. 8 may be combination of alphabet and numbers. Thus, it includes the number from 0 to 9 and alphabets A to F. Hexadecimal to octal conversion. Conversion of hexadecimal to octal cannot be done directly. First, we need to convert hexadecimal into its equivalent decimal number, then decimal to octal. We need to follow the steps. First, consider the given hexadecimal number. Second, first count the number of digits in the number. Third, if n is in the position of the digit from the right end, and then multiply each digit with 16 and -1. Add the terms after multiplication. Resultant is in the equivalent decimal form. Divide the decimal number with 8. Note down the remainder, and then repeat the previous two steps with the quotient until the quotient is 0. Lastly, write the remainder in reverse order.